Now that we know how to import data, we need to now start to talk about how to visualize that data, to look for any patterns, and to start to develop descriptions for our data. And so for this exercise, we're going to use the iris dataset that's built into R. And so to do that, we are first going to import our data, and that's going to be the iris data, so function data, with parentheses, and we're going to call the iris dataset. Run that. And if you look over here, we have our iris dataset, and we're all set to go. And iris has 4 numerical variables and has 1 categorical variable. The 4 numerical are sepal length, sepal width, petal length, and petal width, and the categorical variable is species. And there are 3 species. A quick way to remember what the column names are, what the variable names are, we can use the function names. So if we type, so we're looking for the column names, we use the names function, and names for iris, we run that, and you can see sepal length, sepal width, petal width, and species. Notice that there are periods and uppercase letters in these. These are case sensitive, so you need to make sure when you type these names, you type them exactly as you see them here. So let's do a simple plot. We're going to make a scatter plot. And I'm interested in a scatter plot of the sepal lengths versus the sepal widths. And so here, under this plot, we're going to do a scatter plot. And the basic plotting function is, you guessed it, plot. And so we're going to plot iris. This is the iris data set. Then we're going to write in the $, and then choose the column or the variable that we want in our x-axis. And here I want sepal width in the x-axis. And then we're going to type in a comma, and then we want the sepal length on the y-axis, so we're going to type iris, which is the data set, $, and then we're going to choose sepal length. You can type these in manually if you would like, or you can use these pop-up menus, which are pretty helpful. And so this is the basic plotting function. And we can run it, and there you go. We can sort of move these around by dragging your cursor, and we can see here is a basic scatter plot. We have sepal width on the x-axis, and we have sepal length on the y-axis. Exactly what we asked for. And we have a bunch of points. R defaults into these open circles as the data points. So we can change that quickly. One thing you might notice is that this graph is pretty ugly, and the axes don't look great. And so there's things we can add. And so, to add the things we want in the plot, we add them into the plot function. We tell R exactly what we want. And so the first thing, I think this plot needs a title. And so in this function is the main, or the main title. So we type in main, and the main title equals, and in quotation marks, iris sepal length versus sepal width. Notice that we put the name in quotation marks, and so we're telling R exactly what we want it to say. And so in this case, the main title will say iris sepal length versus sepal width. We now need to add a comma, and this now lets us put more information into this function. I'm going to press enter and tab just to give us a little more room to work around in. And I also want to change the label of the x-axis because it's a bit ugly. And so in R, that's called the xlab, or xlab. And the xlab equals sepal width. We also want to change the y label. And so, of course, that's ylab, ylab. And that equals sepal length. So if we run this again, you can see that the title has changed to iris sepal length versus sepal width. Our x-axis has changed to sepal width, and our y-axis has changed to sepal length. A few other things we can change. We can change the type of point in here. The point is coded as PCH. And PCH is a bunch of numbers, and so we tell it what number designates the point that we want. The one you really want to remember is point number 16, because 16 is the closed circle, and that's the most common one you're going to use. And so PCH equals 16. And so if we run that, the points are now closed. If you don't like the fact that they're colored in with black, you can have it colored in any color you want. So let's say we want them to be blue. We use the command col. So col, or color, equals, and blue, we also want to put in quotation marks. And if we run that, the points turn blue. You can play around with different colors, different types of points in R. I highly suggest you try this out and customize these to your liking. There's a few other things we can do. We can change the x-axis itself, how many tick marks are shown. So, for example, if we want the y-axis to go from 0 to 8, we can, here's another line here, we can write in y-lim, or y-limit, so the limits of the y-axis from the lowest limit to the highest limit, equals, here is concatenate because we're putting two numbers together. The first number will be the lower limit, and here let's say the lower limit is 0. And then the higher limit is, let's say, 10. And so we put limit from 0 to 10. And if we run that, you notice that the y-axis has changed to give us a limit from 0 to 10. We can also change the x-axis to have a different limit. And here, let's say the x-lim equals concatenate, let's see, 0 to 5. And we run that. And there we go. Though, I will have you note that this plot is much uglier now because we are actually hiding some of the pattern. So it's actually not great that this limit is 0 to 5 for the x-axis and 0 to 10 for the y-axis. Not great, and so what we want to do is we can just get rid of it and let R choose for us the best limits. And sometimes that works, sometimes it doesn't. It's really up to you and your decision about what you want your graph to look like and what message it needs to be presenting. And that is basically the plotting function. There are a bunch of other different types of plots you can make. We talked a lot about histograms. And we can plot a histogram. We use the hist or hist function, hist, and in there we want to look at the iris sepal width. And we run that, and there's our histogram. We can also change the color of that, so col equals, let's say, red. We're going to make it red instead of gray. I'm going to run that. And now it's red. Here you can also change your x and y axis just like we did in the plot function. I like the y-axis, we don't need to change that, it says frequency, but the one on the bottom, I want it just to say sepal width. So that is x lab equals sepal width. We run that. And there it is. We can also change the title. Main equals histogram of sepal widths. We run that. And there you go. Plotting in R is not always the most easy task, the most intuitive task. So when we do plots, we will do a few in R, but we'll also be doing them in Excel. I will add an Excel along with this R tutorial. One thing you may want to do is separate the different categorical variables, because here, of course, we plotted the histogram of sepal widths, but this is the sepal widths of all three species. So how do we separate them? We can make 3 new data sets, and we do that by what's called subsetting. And to subset the data is what you need to do. What you want to do is you need to have a new name for one of your data sets. Let's say Setosa, because that's one of the species. So the new data set is called Setosa. And Setosa is a subset of the iris data set, comma, where iris species equals Setosa. Let me break down what all of this means. So the first line, Setosa, is the name of our new data set. And then we have our arrow. And what that means is that everything to the right of the arrow explains what the name to the left represents. And so in this case, the Setosa represents a subset of the full iris data set. So the subset function is what tells R, okay, we're about to subset the data. The next line, iris, tells us what data set we're subsetting from. And so that's the full data set. And the full data set, of course, is named iris. And then we have a comma. And then after the comma, we have what we're subsetting to. And in this case, we're subsetting to species, which is one of the columns in the iris data set. And so iris $species, so the species column within the iris data set. And then we have a double equal sign. And what double equal sign means is equivalency. It doesn't mean equal the way that 1 + 1 = 2. What the equivalency does is R will look through the entire iris data set and take only the rows where the species name is Setosa. It will ignore anything that has versicolor or anything that has virginica. And so what will happen is it will only take 1/3 of the data set. And so if we run this, we look at Setosa up here. Instead of having 150 observations and 5 variables, it only has 50 observations of 5 variables. That's 1/3 of the data. We can then do this 2 more times, but instead we can change the names of the data sets to get versicolor and virginica. And if we run those, you notice now, let me pull this down a bit, you notice now that we have the full data set, that's 150 observations. We have the Setosa data set, that's 50 observations. Versicolor, that's 50 observations, and virginica, which is 50 observations. So what we've done is we've taken the full data set and we've split it into thirds. The first third is just the data from the species iris Setosa. The second third is only the observations from the species iris versicolor, and the third are only the observations from iris virginica. We can check this by clicking on one of these data sets, let's say Setosa, and if we take a look, we have all of our observations here of different things like petal length, sepal width, etc. But if you look at species, there's only one level, Setosa. There's no versicolor, there's no virginica. And so we have successfully subsetted out this data set. And now that we've done that, give that a quick save, we can plot using the subsets. So let's say we want a histogram of Setosa. And we want a histogram of Setosa sepal widths. What we're going to do is we're going to copy that histogram. So we've already written it, so why write it again? We're going to take that and we're going to paste it. And everywhere it says iris, which is just this one spot, you replace it with Setosa. And what we can also do is histogram of sepal widths of iris, or I, Setosa. We run that, and if you notice, the histogram changed, and the data is slightly different. Instead of our histogram of all of the sepal widths, this is just the ones for iris Setosa. We can get a little bit more advanced here. If we want to look at all three iris species all at once, we can actually plot all three histograms at the same time. And the way to do that, we need to use another function called par, P-A-R. Let's make a histogram, or the histograms, of all three iris species. And so what we want to do is we want to use the par function to split our plot window over here into three. And the way we do that is we use the function par, P-A-R. In that function, we need to designate the number of rows in our plot. And the way we do that is we use something called mfrow. So M-F-R-O-W. And mfrow, we need two numbers. We need a number of rows and a number of columns. And so if there's two numbers, we concatenate them together. So we use C, and then we're going to say we want 3 rows and 1 column. And if we run that, nothing happens, but I promise you that it worked. And so now what we want to do is we want to make those 3 plots. And so I want to copy over what we've already done. So again, why type it all out again if you don't have to? And for one of these, we need to change Setosa to versicolor. We also want to change another Setosa to Virginica. And also, let's change the colors of these. So let's leave Setosa as red, versicolor will be blue, and Virginica will be green. Okay? Now I kind of want to make my window for my plot a little bit bigger. You can just drag them around your mouse cursor. And then also, you want to sandwich these in with another par function. And instead of copying this par function, we need to do a new one that will make our window for our plots back to normal. And so, because maybe sometimes you don't want to plot 3 plots altogether. So here we're going to do par mfrow equals, and instead of 3, 1, we just want 1, 1. And that will just be 1 plot and 1 window. So let's run our par mfrow 3, 1. And then let's run our first histogram. If we take a look, we have our plot up here in the top, kind of squished a bit, but there's still a lot of empty space. We run our next histogram, it goes into the middle. And if we run the third one, it goes to the bottom. And so now you have 3 plots all together. And if you move around the window, I'll make it a bit bigger for you, maybe look a little bit nicer. And so now we have the sepal widths of setosa up on top. In the middle we have versicolor, and then at the bottom we have virginica. And this looks great. And now we have all 3 plots, we can sort of compare them. But one thing that you need to make sure to pay attention to is that if we just do these plots and let R pick the X and Y axis for us, the plot might be a bit misleading. If you notice, sepal width for a setosa peaks between 3 and 3.5. But for versicolor, it peaks between 2.8 and 3. But 2.8 and 3 are way over here on the right, even though they should be lower than 3.0 and 3.5 compared to setosa. So these don't really match up. And the same thing is true of virginica. And so when you're presenting multiple plots, you need to make sure that the axes are the same, both the x-axis and the y-axis. And so this is where y-lim and x-lim really come into play. And so what we want to do is drag this back over so we can read it. For the first histogram, we want to make our x-lim, let's see, between 2 and 5. And we want our y-lim to be between, let's say, 0 and 25. And then that's set. To make it the same for the other 2 plots, all you need to do is copy over those new commands, making sure that there is a comma between each command, and that your parentheses all close. And so if we run this again, notice here, 2.0 to 5.0, and then 0 to 25, and so everything is where we want it. We run the next one. There we go. 2 to 5, 0 to 25, and then we have our last one. We run that, and also 2 to 5, and then 0 to 25. And then here, you can see a little more clearly that there are some differences between these species and their sepal widths. And that is the basic plotting functions in R. There's a lot more we can do. These are what I want you to practice for now.